Think about this for a moment. How much of our daily work is made up of completing multi-step tasks that require active and yet routine decision making? What if Gen AI could save you time by automating all the habitual decisions and actions you complete every day? OCI AI Agent Platform marks a new frontier for enterprise automation. Unlike earlier AI tools focused on basic content creation and one-off responses, these agents leverage independent reasoning, memory, and contextual awareness, not only to automate complex workflows, but also to securely access, process, and act on organizational data. Welcome to First Principles, where we explore the cutting-edge advancements in cloud technology. Today, we delve into the fascinating world of Gen AI and evolution towards Agentic AI. We are thrilled to have Egor Pushkin, Chief Architect in Data and AI at OCI, joining us again to discuss the world of AI agents and specifically the OCI AI Agent Platform. Welcome, Egor. It's great to have you back.
Thank you for having me again here, Pradeep. So much has changed since our last conversation about the foundations of generative AI service.
Yeah, definitely. Let's start with the basics. What is Agentic AI?
Sure. Agentic AI is the integration of generative AI capabilities with advanced reasoning, memory, and tool orchestration to enable intelligent systems that can manage complex processes autonomously. Unlike simple prompt-based systems, agents work through multiple steps, retrieve relevant information, call external APIs, and adapt based on interaction history. Agentic systems are a result of steady evolution in machine learning and deep learning.
The world of generative AI has been transforming at an incredible pace. Can you give us a brief overview of how generative AI has evolved to Agentic AI and the significance of it in today's enterprise world?
Of course. Generative AI development is marked by significant milestones. Deep learning and machine learning has led to large language models, or LLMs. Specifically, the adoption of transformer models in natural language processing paved the way for large language models. Early on, LLMs were utilized for single-step tasks, generating text without contextual memory. And later, fine-tuned LLMs emerged for domain-specific activities, improving accuracy. Retrieval augmented generation, or RAG, then enabled AI to access external knowledge, enhancing reliability. Integrated tool use empowered models to interact with APIs and databases, transforming passive assistants into the actual problem solvers. And finally, Agentic AI combines all of these advancements, creating intelligent agents for complex, multi-step workflows and autonomous decision-making. This progression has elevated generative AI capabilities, making it a versatile and powerful enterprise tool.
Right. So every few months, in the last few years, we've had new things pop up in Gen AI world. All the way from fine-tuning to RAG to tool use. And Agentic AI is really, a culmination of all of that, and it really combines the power of many of these innovations that's happened in the last few years.
Yeah, that's a good summary. Agents comprise of three fundamental building blocks. Planning, the ability to make stepwise decisions based on prompt instructions, conversation history, and external context. This includes techniques like reflection, self-critique, chain of thought, and sub-goal decomposition. Tool use enables integration with external tools, APIs, and functions to perform actions. At each step, agent typically interacts with a tool such as search engine, vector store, database, or makes an external API call. Memory brings contextual awareness over multiple interactions, which can be short-term, like retaining the latest user input within a session, or a long-term, for example, remembering user preferences or past tasks performed across multiple sessions.
Well, this is really fascinating. Now, the multi-stage workflows have been part of enterprise applications forever. There's nothing new there per se. So can you tell us what makes Agentic AI such a game changer compared to old-fashioned workflow and automation tools?
From a technical lens, an agent is a pipeline of multiple LLM calls, each performing discrete steps. Parsing intent, selecting tools, retrieving data, evaluating results, and finally responding to the end user. Architecturally, this makes Agent Platform powerful yet modular, which is ideal for enterprises. Unlike traditional static robotic process automation or RPA and rigid workflow definitions, agents are dynamic and adaptive, capable of responding to changing conditions and varied inputs in real time. This flexibility makes agentic technology broadly applicable across domains while reducing the need for extensive upfront configuration and integration. And as a result, organizations can deploy intelligent solutions faster and with greater resilience to operational variability. Agentic AI pipeline can contain multiple agents and their sub-processes being invoked dynamically to obtain desired results or set objectives. This will include agents that can be fully autonomous and the ones that can involve human in the loop.
So the key here is that the agentic plan itself is actually dynamically determined using specialized AI models, it looks like. That's really cool. So it is almost like writing code on the fly, if you will. So what type of model do we use to generate the plan, and how do we actually do it?
We use fairly large-sized models with powerful reasoning capabilities to generate the actual plan. And we have specially tuned prompt and context that are engineered for plan generation.
Got it. Well, that clearly is an important part of the agentic infrastructure, right? So, can you walk us through how agents are built?
Absolutely. OCI AI Agent Platform provides a seamless, fully managed environment for building and deploying AI agents. When provisioning a new agent, users are given a rich and modular design framework to configure every aspect of the agent's capabilities. This configuration process includes defining the knowledge base, providing instructions and model family, enabling tool use, and finally configuring the endpoint.
Got it. So let's dive into the practical implementation of agentic AI. What are the initial steps to set up an AI agent for enterprise use case?
The process begins with knowledge gathering and organization. You identify and define the knowledge bases that the agent can access, which could be unstructured data like documents or structured data stored in Oracle database 23.ai with its advanced search capabilities. This step helps ensure the AI has solid foundation of information.
Wait, so this is actually important to note. This part of actually selecting, the knowledge base, if you will, is actually done by humans, not done by AI per se. This is typically enterprise IT staff. And we do this for, very good practical reasons, including security reasons, right? Like it is important for enterprise to make conscious and deliberate decisions on what data sources specific AI agents should leverage, right?
Yes, that's right. For databases, you can configure the SQL endpoint, allowing the agent to communicate with structured data in databases using natural language. For instance, translating a sales-related question into a SQL query. Then you customize the AI's tools to fit your enterprise needs. This involves creating interfaces to connect with internal tools, APIs, or external services. This step enables agents to interact with your business's unique ecosystem. You also define instructions for the agent's behavior, tone, and response strategies, and choose the right LLMs to power the agent's intelligence.
Well, that's really impressive. So, after these configurations, how does the AI agent become accessible to the user?
The agent is deployed via creating a dedicated endpoint. Users interact with it through a chat interface, an embedded widget, or even a programmatic API. It's designed to handle complex conversations and provide a seamless human-like experience, all while keeping the underlying infrastructure hidden away from the end user.
Got it. That makes sense. So, at OCI, obviously, security is so foundational. How is security handled in the context of agentic AI framework?
OCI AI Agent Platform is built from the ground up with the security as its foundation. Every layer of the platform, from data ingestion to response generation, incorporates robust controls designed to protect sensitive information, enforce policy boundaries, and helps ensure responsible use. This security-first design empowers organizations to confidently deploy intelligent agents across even the most regulated industries. At runtime, agents are deployed in isolated, secure environments. OCI Agents Platform supports dedicated inference infrastructure and strict separation of tenant data, which is vital for industries like healthcare and finance. Security is enforced via multiple facets at the forefront of OCI's agent platform, and they are agent guardrails, client-side execution, and hallucination prevention.
Let's deep dive into each one. So let's look at guardrails. What are those?
Agents include guardrails that constrain behavior and enforce organizational norms with a strong focus on two critical aspects of safety: request understanding and response verification. On the input side, guardrails help agents interpret requests accurately and within safe boundaries. For example, request parsing mechanisms help ensure that user intent is correctly extracted and matched to allowable operations. In case of a SQL agent, this might mean validating that a natural language question can be safely translated into a select query without unintended consequences. On the output side, response verification is essential for ensuring that what the agent returns is not only correct and relevant, but also compliant and contextually appropriate. In retrieval-augmented generation pipelines, this includes checking that cited sources are correctly attributed, that hallucinations are minimized through grounded data references, and that generated responses are validated against expected formats or business logic.
Right. So this is like, the guardrails that we had in RAG for a while. It's like a set of rules for response verification using grounded data references, business logic checks, and even formatting checks, really. So, you mentioned client-side execution. What is that?
OCI Agent supports client-side function invocation, a powerful capability that allows agents to interface with customer-managed APIs while keeping sensitive responsibilities such as authentication, authorization, and networking within the client's tenancy. This approach is particularly valuable for enterprises that need to retain strict control over how and when their internal systems are accessed. With this setup, the reasoning and decision-making of the agent, everything from parsing the user intent to determining which tool to invoke, runs entirely on Oracle's backend. Once a specific function is selected by the agent's reasoning engine, the invocation securely delegated to the customer's environment for execution.
Got it. So obviously in an enterprise IT environment, it's, the clients are going to be different, but instead it may be a functions in customer tenancy, that has access to specific, credentials. Now, you also mentioned hallucination. How do we, prevent hallucinations with these models in the agentic infrastructure?
Goal with hallucination prevention is to ensure that agent responses are not only relevant, but also verifiable and grounded in accurate data. We take multi-layered approach to this challenge. In context of SQL-based interaction, hallucinations are mitigated by grounding the agent's behavior in strict schema definitions. By linking SQL generation to a well-defined schema, specifying table names, column types, and permissible operations, agents are prevented from generating invalid or speculative queries. Furthermore, a self-correction mechanism allows the agent to detect errors in SQL execution, like syntax issues or missing references, and revise its query accordingly without user intervention. For RAG, hallucination prevention is achieved through a combination of post-verification and citation checking. Once a draft response is generated using retrieved documents, the system verifies that the information presented matches what exists in source material. This not only helps validate the content, but also brings and builds the trust with end users. For custom tools and APIs that return structured responses like JSON payloads, the agent restricted to defined functions and expected outputs, reducing the possibility of generating speculative or inaccurate information. Collectively, these techniques, schema constraint generation execution-aware self-correction, citation-based verification, and deterministic tool responses form a comprehensive framework for reducing hallucinations.
Well, that's really great. Obviously, reducing hallucination is absolutely critical for any enterprise use of AI. How is OCI AI Agent Platform used in Oracle and our own ecosystem?
OCI AI Agent Platform serves as a foundation within the Oracle Enterprise App ecosystem, just like it does for Customers Enterprise App. It deeply integrates with Oracle's native technologies, leveraging advanced capabilities of Oracle database, such as vector search for semantic retrieval and native SQL engines for structured queries. These integrations allow agents to access and reason over enterprise data with precision and speed. On the other hand, applications like Oracle Fusion, NetSuite, and healthcare can embed intelligent agents natively into their workflows, enabling personalized, context-aware, and proactive user experiences. The Agents platform provides not only the infrastructure and reasoning capabilities, but also brings the security, observability, and orchestration patterns required for deploying intelligent automation at scale across Oracle Cloud ecosystem. As an example, Fusion applications embed intelligent agents directly into HCM, ERP, and CX workflows to provide contextual, proactive, and personalized assistance to users. These agents can surface insights, answer questions, or even complete tasks based on user behavior and system state, all without the need for users to leave application interface.
Got it. That's really awesome. So can you give an example, on how OCI Agent Platform is actually used internally in Oracle?
Yeah, let's take a look at HCM application. An employee initiates an interaction by submitting a request in a natural language. The agent service analyzes the request and decomposes it into a series of subtasks to be executed sequentially. The first subtask involves identifying the appropriate function needed to retrieve relevant details. Execution of the corresponding API call is delegated to the orchestrator within the Fusion environment. This helps ensure that all calls are properly authorized and eliminates unnecessary external exposure of HCM APIs in this case. The agent then retrieves benefit plan details from the appropriate knowledge base. And finally, a calculator tool is invoked to compute the result, which is passed through a response generation pipeline and delivered back to the end user. So this entire interaction is abstracted away from the customer, and the architecture supports a wide range of tool and knowledge-based combinations across the Fusion application landscape.
Well, that's really impressive. So it's clearly, the OCI agent, platform is already paying dividends in terms of, delivering agentic workflows in the context of, Fusion apps and NetSuite. What are some of the advancements we can look forward to?
The agentic AI landscape is evolving incredibly rapidly, with new paradigms, tooling methods, and orchestration strategies emerging almost monthly. From foundational innovations like React-style stepwise planning to emerging multi-agent collaboration models, Oracle Platform is built to evolve in lockstep with the field, ensuring the customers can adopt new capabilities without disruption. Moving forward, the service will expand to support custom hardware and proprietary LLMs, incorporate emerging agentic patterns such as deep research, and integrate multi-agent topologies along with standardized communication and interoperability frameworks.
Well, that is really wonderful. Well, Egor, thank you so much for sharing all the details about OCI AI Agent Platform.
It's my pleasure. Thank you, Pradeep.
Here are some of the key takeaways from our discussion. OCI AI Agent Platform enables enterprises to leverage GenAI to build intelligent, secure, and context-aware agents. The agents are provisioned using declarative configurations for knowledge bases, SQL endpoints, custom tools, and behavioral instructions. Security is built in across the framework. Agent guardrails and hallucination prevention are core design principles and enforced through schema constraints, post-verification, and citation-based validation. OCI AI Agent Platform comes with native integration to Oracle technology such as Database 23 AI and forms a foundational building block for Oracle applications such as Fusion and NetSuite to deliver seamless in-context automation. Thank you for joining us.